Hi guys, for today's video, we are going to talk about exponential functions, equations, and inequalities. And for the reference of my students, you can read it on your books. So we have the first one, page 117 to 123, and then we have page 143 to page 147. Okay, so sit back and relax, and please prepare the following materials before you begin. Before we begin, like your paper, your notebooks, your pen, your calculator, so that you can cope up with our discussion. All right. So when we say exponential function, guys, it is defined by the rule f of x equals a raised to the power of x. So as you can see in the general equation of exponential function, we have f of x. It means that this is the range, okay? And also, this is the input. And the input or the domain is actually an exponent. So it means that the elements of the domain are in the exponent, okay? So where a is greater than 0 and a is not equal to 1, what do we mean by that? So the exponent or the base, so which is a, must be greater than 0 and, of course, not equal to 1. Okay, so those are the things that you have to remember. When we are talking about exponential function, we have the unknown value in the exponent part or power. And of course, we have the base, which is the where the power or the exponent is raised, wherein the base must be greater than 0 and it's not equal to 1. So the following are what we call exponential functions. So just like this one, we have y is equal to 8 raised to the power of x. So for all we know, y means range, and y can also be written as function of x, h of x, and so on and so forth. And of course, we have 8, and as you can see, 8 is greater than 0 and it's not equal to 1. That's why it's the perfect base for this exponential function example. And then, as you can see, the exponent is an unknown value, which is the domain. Okay. And then the other one, we have y is equal to 5 raised to the power of 3x. So as you can see, this is the power or exponent. The base is greater than 1 and not equal to 1, or greater than 0 and not equal to 0. And also we have y. So when we say greater than 1, greater than 1, it means that the number is positive and it's not also equal to 1. And here we have y is equal to 2.5. Okay, and we have decimal as a power. So the only condition is that the base or a must be greater than 0 and it's not equal to 1. It's any real number other than 1 and it should be greater than 0. So we can have fraction, we can also have decimals for as long their values are greater than 0 and not equal to 1. Now, so let's have the graph. So as you can see, the graph is a curve, okay? So it goes up to the right. So it depends on the given exponential function. So we will have a simple example about graphing. And then after that, we will proceed in solving equations and inequalities of exponential functions, okay? So let's have exponential functions. Let's examine this. So we have the table of values. We have x and the range, which is 2 raised to the power of x. Just remember that this specific column contains the elements of the range, and this specific column contains the elements of the domain. All right. So our general function is y, or f of x, is equal to 2 raised to the power of x. Okay. So how can we solve for the range, which is the y? So when you are graphing in a table of and you are going to use a table of values, so you have to make sure that you will be making an assumption of your domain. So just like this, we have the assumption for the first column, and then to get the values of the range or the elements of the range, which is the second column, all you need to do is to substitute the value of x, okay, to the given function. So just like this, if the value of x is 3, so we can just simply, or you can also write f of x equals 2 raised to the power of x. And if the value of x is 3, just simply substitute f of 3 is equal to 2 raised to the power of 3. And of course, when we say 2 raised to the power of 3, it means that you are going to multiply 2 to itself how many times? 3. In this case, we have 2 times 2 times 2. Because the power is 3. Then the answer is 8. So that is the value of y, or the range, if the value of x is 3. And then we also have the value of x, which is 2. So all you need to do is to substitute f of 2 is equal to 2 raised to the power of 2, or 2 squared. This means that we have 2 times 2 equals 4. So we are just multiplying it to itself, or we are just simply multiplying the base to itself. And then if the value of x is 1, so f of 1 is equal to 2 raised to the power of 1. When you raise the number of course to 1, the answer is the number, or the base. Okay? In this case, it's 2. And then how about if the domain is 0? So just simply substitute f of 0 is equal to 2, which is raised to the power of 0. And then 0 law of exponents says that when you raise a number to 0, the answer is always 1. Except 0, of course. So when you raise 0 to 0, the answer is still 0. But if you will raise a number, or any real number, which is not 0, okay, the answer is always 1. So just like this, if we have 2 raised to the power of 0, the answer here is 1. That's why our range is 1. Next is we have f of negative 1. So if we will be raising 2 to the power of negative 1, so in this case, we use 0 law of exponents, but in this case, we're going to use negative law of exponents. So when we say negative law of exponents, if the power or the exponent is negative, you cannot yet simplify that. So what you need to do first is you have to reciprocate. Okay, so you are going to interchange the numerator and the denominator, right? So that you will be able to simplify the given power. Now in this case, we have 2 raised to the power of negative 1. This means that since we have negative 1 as an exponent, we cannot simplify it yet, rather without even reciprocating. So it's now 1 over 2 raised to the power of positive 1. 2 raised to the power of positive 1 is simply 1/2. Alright, so I hope you are learning. So you've studied this, I think, in grade 7 and grade 8, the laws of exponents, even in grade 9. So you have to remember, we have multiplication law of exponents, division law of exponents. So we have power to a power, okay, product law, so on and so forth. And the other two are 0 law of exponents and negative law of exponents. And then if the value of x, or the domain, is negative 2, we have f of negative 2 equals 2 raised to the power of negative 2. Reciprocate it first. Just remember that when you are reciprocating, you are interchanging the numerator and denominator. In this case, the denominator is 1. You will put it in the numerator over 2 squared. So when you reciprocate, don't forget to remove the negative sign. So this is now equal to 1 over 4, because 2 times 2 is 4. Okay, so that's why our answer is 1/4. And then lastly, if we have f of negative 3 equals 2 raised to the power of negative 3. So we still have a negative exponent here. All you need to do is to reciprocate. So we have 1 over 2 raised to the power of 3, or 2 cubed. So if you are going to multiply 2 to it, so 3 times, just like what we did here, so we will have 1 over 8. So just remember that you cannot solve the range without the elements of the domain. Right? So this is our general function. We have the base, and of course we have the exponent. And then how are we going to graph it? So for you to be able to graph it, we will start with, let's say we will be start with the middle. We have 0, 1. X is 0, and then y is 1. So we will begin from 0 going up because it's positive 1. So this is now the point. And then followed by 3, 8. You can go in any order for as long as the plotting of points that you're going to do are that is correct, rather. So 3 and 8. So x is 3 and then y is 8. Okay, so we have 3 for the x-axis and then going to 8. All right, so this is the point. And then we have 2, 4. Okay, this one, 2, 4. So 2 for the x and then 4 for the y, and then you're going to intersect them. That's why the point is here. And then the other one, we have 1 and 2. We have 1 and 2, this one. So 1 is for x and then y is 2. And then you are going to intersect them to plot the point. And then we have 0, 1. Okay, we're done with that. And then we have negative 1 and 1/2. So this one. And then we have negative 2 and 1/4. And then lastly, we have negative 3 and 1/8. All right? And of course, there's a line. There are lines that the graph will avoid, like the horizontal asymptote and the vertical asymptote. Okay, so that's the idea for graphing. But now, right now, you can just simply use some applications like Desmos or Photomat so that you can actually easily graph the function. So we are in the modern age. That's why you can also use those things, no? So when you graph functions or specifically exponential functions, all right. And then of course you have to draw the line. The graph of f of x is equal to 2 raised to the power of x is this. And then, why should you learn this? So, some conditions in life increase and decrease tremendously. So, for as long as if the problems that we are encountering in real life are sometimes increasing and decreasing, okay, we are talking about exponential functions or growth or decay. So, just like the following, if we have compound interest for a period of time, so the interest is increasing depending on the period of payment that you have chosen. And then we also have growth of bacteria, decay of bacteria, okay, growth of virus and any microorganisms. And of course, we have the depreciation of a car. So when we say depreciation of a car, since car is just is one, okay, rather than it's needed. Okay, so for a period of time, the price of the car is getting lower. So that's what we call depreciation, right? So it's not actually a positive investment. Rather, if you really need the car, just buy a car. But if you don't need the car and it's just for luxury, do not buy because for a period of time, the price is depreciating or going down. All right. Next, let's talk about property of equality. So in this case, we're able to solve exponential equations and inequalities. So if b is a positive number other than 1, then a raised to the power of b and is equal to a raised to the power of c. So as you can see, if the bases are similar, you can just simply equate the exponents. So that's what we mean with the property of equality for exponential equations. Alright, so just remember that you have to make the bases similar for you to be able to equate the exponents. So make this similar for you to be able to equate the exponents. We have b and c here. For you to better understand this, let's have the following example. First example, we are going to solve for the solution set or the value of x. So solve for x in the function 4 raised to the power of x minus 2 equals 64. So how can we solve and how can we apply the property of equality here? So just remember that we have to have similar bases. In this case, we have 4 and 64 as the bases. But the thing is, get the lower one, which is 4. And then for 64, the goal is, how can we make this 4? So that's the question. How can we make it with a base of 4? But the question is, what is the exponent of 4? Okay, when you simplify, you will get 64. So that's the idea. We have to make 64 4, okay, with the power or exponent that will make it back to 64. So that's the idea that we're going to use here. So we will be using the base of 4. So again, our goal in the inequality, okay, so is to make the bases similar so that you can equate the exponents. So in this case, we're going to make 64 4. So just bring down this one, x raised to the power of x minus 2 equals 64. Now, what are we going to do? How can we factor? The idea is, how many 4s are you going to multiply to get 64? So you will be starting from 4 times 4 equals 16. And 16 times 4 is equal to 64. How many 4s did we multiply? We have 1, 2, 3. So that's it. We have 4 raised to the power of 3. And 4 raised to the power of 3 is 64. Okay? So we are able to make 64 4, okay, raised to a power which will make it back to 64. That's the idea. So since we already have similar bases, what can we do now is to solve for x. We can now equate x minus 2 equals 3 and apply some algebraic techniques to get the value of x or the solution set. So we have to isolate x, transpose negative 2, 3, of course opposite sign, it's positive 2. So x now is equal to 5. So x is equal to 5. If there is a question in mind, how about 2? Can we use 2 as the base? So let's try. If you are going to use a different base, okay, you have to make sure that you have the same value as well. So in this case, what if we're going to use 2? The question is, how can we make 4 a 2? Of course, we have to multiply the factors of 2 or 4, okay, to get 4. So in this case, 2 times 2, how many times will you multiply 2 to itself to get 4? Twice. So 2 times 2 equals 4. So in that case, how many? We have 2 2's. So 2 squared times the original exponent. Okay, so the operation is multiplication, x minus 2. And then for 64, how many 2's will you multiply to get 64? So let's start with 2 times 2 equals 4. 4 times 2 equals 8. And then we have 8 times 2 equals 16. 16 times 2 is 32. And lastly, 32 times 2 is 64. And then you now count. 1, 2, 3, 4, 5, 6. So 2 raised to the power of 6 is equal to 64. Can we now equate, teacher? Yes. So you bring down 2 times x minus 2 equals 6. Alright, can we now solve for x? Yes. First is distribute 2 to the binomial. 2 times x. Okay, and then 2 times negative 2. Our answer is 2x minus 4 equals 6. And then of course we have to isolate x. Bring down 2x equals 6. Transpose negative 4, this will become positive 4. Okay, so 2x is equal to 6 plus 4 or 10. Then, lastly, we have to isolate x by removing 2. So we will divide both sides by 2. X now is equal to 10 divided by 2 equals. So as you can see, they are the same. Alright, so for you to better understand, let's answer number 2. Solve for x. We have 16 raised to the power of negative x equals 1 over 64. So how can we solve? So we have 16 and 64. We cannot use 16 as a factor. Why? 16 times 16 is not 64. Okay, so it means that we are going to use a factor or base which is common to 16 and 64. What is that? Teacher, can we use 4? Yes, let's see. So what if the base is 4? So how many 4 are you going to multiply to get 6? So just multiply 4 times 4, 16. I mean 16. Okay, so we have now how many? 1, 2. So 4 square, okay, 4 square times negative x, the original exponent, equals, so don't worry that this is a fraction. We can apply the law of exponent here to remove the fraction. So 64. How many 4 are we going to multiply to get 64? Just continue this one. 16 times 4 equals 64. How many? 1, 2, and 3. So it's now 4 raised to the power of 3. So how can we make this? How can we remove this from a fraction? So this is what you're going to do. You are going to apply now negative law of exponents. So just bring down 4 raised to the power of 2 times negative x. And then, the idea for negative law of exponents, for you to remove negative, you have to reciprocate. And then, for you to reverse back to a negative exponent, you have to reciprocate again. In this case, the numerator, which is 1, will go to the denominator. And then, the denominator, which is 4 cubed, will go to the numerator, but the exponent will become negative. Or simply, we can rewrite this as 4 raised to the power of negative 3 equals 4 raised to the power of 2 times negative x. In that case, they are already, or the bases are already similar. So therefore, we can equate the exponents. We have 2 times negative x equals negative 3. Okay? And then after that, multiply this. So 2 times negative x is negative 2x equals negative 3. And then for the final touch, we have to divide both sides by negative 2 because we need to isolate x. So, okay, so just cancel this one. X is equal to negative 3 divided by negative 2. So this is still fraction, but the thing is, this will become positive because we are dividing both positive. 3 over 2 is the final answer. Can we make it a decimal? Yes. If you want, you can have 1.5 as the answer. Okay. So, teacher, can we also use the base of 2? Yes, of course, you can use the base of 2. So, if you're going to use the base of 2, same process, all you need to do is to make the bases 2. So, for 16, how many 2's will you multiply to get 16? 2 times 2 is 4. 4 times 2 is 8, and then 8 times 2 is 16. So, we will have 4 2's. So, 2 raised to the power of 4 times negative x. And how about for the other side? How many 2's will you multiply to get 64? Okay, very good. So, you are going to multiply 2 6 times. So, 1 over 2 raised to the power of 6. So, we will still be using negative law of exponents. So, we will have now 2 raised to the power of 4 times negative x. And then here we have 2 raised to the power of negative 6. So we will reciprocate same as the first one. And then we can now equate the exponents. 4 times negative x equals negative 6. So distribute 4. So 4 times negative x is negative 4x equals negative 6. And then we need to divide both sides by negative 4. So cancel. We will have x equals positive 6 over 4. Or simply, so the lowest term of this one is 3 halves. Or you can make it also 1.5. See? So if you're going to use a different base, you have to make sure that you will be able to get the final answer or same answer. Alright? Same value of x. Or the other tip for this one, you have to make sure that when you actually expand or a specific number to a specific base with the power, you have to make sure that it's equal to original number. So, like for example, 64, and if the base of 64 is 2, so we have 2 raised to the power of 6. So, it means that when you multiply 2 to itself 6 times, you should be getting 64. And then that's it. You can now equate if the bases are similar, and then apply some algebraic techniques for you to be able to solve for the unknown value or solution set. Next. So here are the solutions. For my students, I'll be giving you a copy of this so for you to review. Next, let's have example number 3. So for example number 3, let's solve for the value of x. So in this case, as you can see, this is very easy. We cannot anymore get another lower base than 2 because 2 is a prime number. So we can just copy 2 raised to the power of 2x minus 1. And here 4, how many 2's will you multiply to make it 4? 2. So 2 squared times 3x plus 2. And then after that, since the bases are already similar, you can equate the exponents. 2x minus 1 equals 2 times 3x plus 2. And then distribute this, you will be getting 2 times 3x is 6x, and 2 times 2 is 4, equals 2x minus 1. Then we will be combining the similar terms as well. So 2x, and then opposite transpose 6x, it will become negative 6x, and bring down 4, and then transpose negative 1, this will become positive 1. So 4 plus 1 is 5, and 2x minus 6x is negative 4x. And then divide both sides by negative 4. Alright, so cancel negative 4. X now is equal to negative 5 over 4. So that is now our final answer, or the value of x. Okay, so if you have questions regarding the examples that we're answering right now, you can just simply message me with my social media accounts. So let's have example number 4. So for example number 4, solve for x. This time it's inequality. So in the inequality, 4 raised to the power of x plus 3 less than 8 raised to the power of x plus 1. So don't be confused of this. It's just the same as the previous examples. So same thing, we have to make the bases similar. So 4 times 4 is not 8, it's 16. So that's why we are going to use a base which is lower than 4, and that is 2. So how many times will you multiply 2 to itself to get 4? We have 2 times x plus 3, which is the original exponent, less than, okay? How many times will you multiply 2 to itself to get 8? 2 times 2, 4, times 2, it's 3 times x plus 1. You can now inequate them. Rather, you can inequate now the exponent. So we have 2 times x plus 3 less than 3 times x plus 1. And then the next thing is we will distribute. So the monomial to the binomial. So the monomials to the binomials, because we have 2 pairs. Now 2 times x is 2x and 2 times 3 is 6. Less than 3 times x is 3x, and then 3 times 1 is simply 3. Then we will be combining similar terms. You bring down 2x, transpose 3x, it will become negative 3x, less than, bring down 3, and then transpose 6, it will become negative 6. Then 2x minus 3x is negative x, less than 3 minus 6, it's negative 3. And then divide both. To isolate x, there's an invisible negative 1 there, so we have to divide negative 1 on both sides. Alright? Now, for inequality, there's a rule that you need to flip if the divisor, if and only if the divisor is negative. In this case, are we going to flip the less than? Yes, because the divisor that we used is negative. So it's now x greater than positive 3. Because negative 3 divided by negative 1 is positive. So our final answer is x is greater than 3. Do not confuse yourself. We just use the same process as the previous examples in solving for the inequalities. Next. So here are also the solutions. They're just the same. Next example for inequality. So we have to solve for x in the inequality 3 raised to the power of x plus 1 greater than 243. Don't worry, this is very easy. We don't care if 243 is a very, it's quite higher, no? So there's no problem with that. So our base is 3. And our goal is how can we make the base here, which is 243 a 3. Alright, so same thing, we are going to multiply 3 to itself until we reach 243. So 3 times 3 is 9. And then 9 times 3 is 27. And then 27 times 3 is 81. And then 81 times 3 is, of course, 243. How many 3's did we multiply? 1, 2, 3, 4, 5. So we have 3 raised to the power of 5. So are they now? Do we have now similar bases? Yes. So you can equate you can inequate the exponents. We have x plus 1 greater than 5. Then transpose 1, x greater than 5 minus 1. So x is greater than 4. Do we need to flip, teacher? No, because we did not multiply or we did not divide both sides by a negative number. So our final answer is x greater than 4. And then we have the last for inequalities. Solve for x in the inequality 2 raised to the power of negative 4x plus 1. And the symbol is at least or less than or equal to 512. So of course, the base that we're going to use is 2. It's a prime number. Raised to the power of negative 4x plus 1 at least or less than or equal to 512. So, but 512, we have to make it as 2 raised to a power to get 512. So the question is, please compute how many 2's will you multiply to itself to get 512. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Very good. We will multiply 2 to itself 9 times. So we have now similar bases. All we need to do is to equate. So negative 4x plus 1, at least 9. Then, of course, we can now transpose 1. It will become negative 1. And then negative 4x, at least 9 minus 1 is 8. We need to divide both sides by negative 4. So x, okay, are we going to flip? Yes, because the sign or the divisor is negative. So it's now at most or greater than or equal to 8 divided by negative 4 is negative. So the final answer is x is at most negative 2. Alright? Next. So I hope that you're able to follow and cope up with our discussion about exponential equations, on how to solve exponential equations and inequalities. Alright. Now, so here are also the solutions for these two examples, or last two examples. Now, let's apply exponential functions to real life. Right? So in this case, let's have the equation or function for decay or growth. So just remember, we have the equation y or function y is equal to ab raised to the power of t. Just remember the parts when we say a, we have the starting value. If we're talking about population of people, let's say in 2005, we have 100,000 for Pampanga. Alright, so that's our starting value. And then, of course, the ending value. What if in 2005 we have 100,000? What if what is the population now in 2010? Those are the questions. So what's the ending value? And then, of course, we have the factor, growth or decay factor. This will indicate the amount of increase or decrease of a specific population. And then T means time. How many hours, seconds, minutes, how many days, how many weeks, months, or years. Okay, for the decay or the growth. Let's have the first problem. So for the first problem, this is the simplest possible problem that you might encounter. In 2005, a certain town in La Union has a population of 32,400. Each year, the population increases with a growth factor of 1.07. So, and then the questions are, determine an exponential equation that models the population growth in T years. And for letter B, using the equation in A, determine the population of the town in 2010. So we will start with 2005. Alright, so and the population that we need to solve is the population in 2010. Now, let's label 32,400 is our A. Or what do we call A? The starting value. And of course, we have 1.07. This one is what we call the growth factor because we're talking about population. And then, of course, to determine the exponential equation that models the population growth in 10 years, of course, our ending value is unknown, which is y, equals the value of A, or the starting value, which is 32,400, times our factor or growth factor, which is 1.07, raised to the power of t. So we just need the equation. Okay, when it's asking for equation, so you don't have to substitute something to the years. All you need to do is to substitute to A and B, the starting value and the growth factor. Now, using the equation in A, determine the population of town in 2010. Okay, so since we're talking about population, the final answer must be rounded up to the nearest whole number because we can, let's say the answer is 10,000.5. We cannot make a specific person to half, right? So that's why you have to round it up to the nearest whole number. Now, substitute y is equal to 32,400 times, okay, in your you can now use your calculators, 1.07 raised to the power of how many? 2010. We have 2010 here. You need to subtract the years. So 2010 from 2005 to 2010. So 2010 minus 2005 is equal to 5 years. So we have to raise it to 5 years. And then after that, simplify using your calculators. If you have your calculators, all you need to do is to enter 32,400, open parenthesis, 1.07. Okay, close parenthesis. And then you will be seeing on your calculators, it might be a second function or shift. You may have to click the shift first before you can see this. Okay, this symbol. So, and then after this symbol, we have 5. Alright, so what is the answer? The answer now is 45,443 population in La Union in 2010. Okay, so how did we arrive? So y is approximately. So we are using the word approximately because we rounded off the answer to the nearest whole number. So what is the original answer? So 32,400 times 1.07 raised to the power of 5. Okay, so the original answer is 45,442.68. Okay, so we can now round it up to the nearest whole number. We will be adding 1 because as you can see, 0.68 means more than 5. So you will be adding 1. 5 or more for 5 or more. So in this case, it's 45,443. Don't forget to put the label population in 2010. Alright, so to my students, please focus in this discussion about problem solving of exponential function because this is the reference of your performance. And then let's talk about bacteria. Let's see if this is growth or decay. Let's read the problem. A total of 32,000 bacteria cells were initially present at the start of an experiment. These bacteria cells were placed in a condition that inhibits decay. After 5 years, there were only about 1,000 cells. So it's a decay because from the original population, which is 32,000, it's now only 1,000 cells. So A, determine the decay factor of the cells. B, determine an exponential equation that illustrates the number of cells left after 3 hours if the number of cells changes at a constant rate. So using the equation in B, how many cells are left after 10 hours? Now, let's analyze the problem. In the problem, we have, of course, the starting value, which is 32,000. And then we also have 1,000 cells, which is the ending value if the time is after 5 hours or 5. Now, the question is, how can we solve for the decay factor? We don't have the decay factor or the B. We don't have the decay factor or the B. So this is actually, this is the ending value if we have after 5 hours. Now, how can we do that? Let's go to this one. Determine the decay factor. So for you to be able to determine the decay factor, let's have the given values in the problem. So your A is 32,000, and then your Y is 1,000, and then that is after 5 hours. In this case, we can now make this 3 given values as reference to solve for B. Just remember that you cannot solve for the ending value without the value of B or the growth or decay factor. In this case, we have the decay factor. And then after that, we will be using the general equation or function, which is y is equal to AB raised to the power of t. Then after that, we have 1,000, which is the ending value, substitute it. And then after that, we have A, which is 32,000. And then bring down B raised to the power of 5 years, or rather 5 hours. And then you have to isolate B raised to the 5th power by dividing both sides by 32,000. So 1,000 divided by 32,000 is just simply 1 over 32 equals B raised to the 5th power. Then the next thing is, we still have the exponent of 5 here. How can we remove it? We have to extract the root of both sides. So for you to remove 5 in B, okay, so you have to have 5th root of B raised to the 5th power. So just cancel this. How can we simplify 5th root of 1 over 32? So to simply simplify this one, go to your calculator. So I think this is a second function. So just look for this symbol. So if you have already that symbol, of course, you have to change this to 5th root of what's inside the fraction symbol 1 over 32. Okay, so that's how you will do it. So if you are going to do that, or maybe you can translate first 1 over 32 to decimal for you to be able to easily simplify it. Right? Now, what if teacher, if I'm going to do this? So if I'm going to click this radical symbol. So we have 5 fifth root of. What if inside I'm going to put only 1 divided by 32? Other than 1 over 32 because teacher, I don't know how to input fractions. So it's also okay. The answer, if you're going to do that, is 1/2 or 0.5. The decay factor now that we can use is 0.5. Next. Now, from there, we can now determine the exponential equation that illustrates the number of cells left after t hours if the number of cells changes at a constant rate. So, of course, simply substitute A and B. Alright, so our A and B originally, we have 32,000 and then 0.5, which is the decay factor. And then this one is the starting value. And of course, raised to t because according to the question, that after t hours. Now, this is the basis now to solve for the last question. Using the equation in B, how many cells are left after 10 hours? So we can simply substitute the values. Alright, so we have 32,000 times 0.5 raised to the power of 10. So you can directly input this one on your calculators to get the answer, which is approximately 31. So again, it's approximately because the answer is in decimal form. So if you're going to simplify that, 32,000 times, or open parenthesis, 0.5 raised to the power of 10. This is now equal to 31.25. So 31.25 is 31. So we are talking about bacteria. We cannot actually split a single bacteria into half or into 1/4. Okay, so that's why you need to round it up to the nearest whole number. So the final answer is we have 31 bacteria after 10 hours. Right, next. Problem solving 3. Let's have virus. Let's see if this talks about growth or decay. Laboratory findings show that the SARS-causing coronavirus, upon reaching maturity, increases drastically every hour. How many cells of the virus will be present after 24 hours? Let's refer to the given data. So at 8 a.m., it started from 2. So, and 2 is what we call our starting value, or 8. And then, of course, so in 9 a.m., after 1 hour, we have 4. After 2 hours, we have 8. And after 3 hours, we have 16. So we only have the initial and the ending value to solve for the growth factor. So you can solve for the growth factor if you will be making 4 as your ending value. But in the question is, we have to solve the 24 hours. After 24 hours. Then the next thing is determine the growth factor. How can we determine the growth factor? We will be using this as A and Y, which is 4. And then of course we are looking for the growth factor. So this is just for 1 hour. 1 hour is your time now to solve for the growth factor. Then substitute the values to the equation y is equal to ab raised to the power of t. We have 4 is equal to 2b raised to the power of 1. Then to isolate b raised to the power of 1, or b raised to the power of 1, rather, it's, we can cancel this one, divide both sides by 2. Our growth factor is 2. Can we now solve? But don't be excited, we have to write first the equation after t hours. So just substitute a and b. For a, we have 2. And then for b, we have 2 as well. So substitute, we have y is equal to 2 times 2 raised to the power of t. So our starting value and our growth factor are the same. And after that, we can now solve for the 24 hours. So y equals 2 times 2 raised to the power of t. So substitute the values and just simply use your calculators in solving this. So you will now have, this is not approximation because as you can see, the answer is the exact. So y is equal to 33,554. 33,554,432 after 24 hours. So just imagine that if you accumulated, if you got coronavirus last 2 years, okay, so in that specific year, coronavirus is very strong, unlike now. So after 24 hours without treatment, you will have 33,554,432 virus inside your body. So that's what. That's how we can apply exponential function for growth or decay problems. All right, so for my students, of course, you need to do this, and then I'll be posting on your learning management system where you can actually submit this for a specific due date. Thank you for listening. I hope that you've learned a lot. Don't forget, subscribe on my channel, Teacher Dong. Have a nice day. Thank you so much for listening.